Quiz 2. Who's my favorite student? Sadly, it's not any of you. I know you like to think that. My favorite student is good old Anne. Number 1. First of all, if I look at number 1, are we moving at relativistic speeds? Are we moving near the speed of light? I'm not going to be using t0 and t, but it definitely wants me to find t. Okay. Is there more than one object moving at different speeds? This is a job for relative speed. So I'm going to assume that A is 0 because Mr. Dewick said we're going to keep two objects moving fairly simple. We could have them also accelerating. It's doable. See me during a flex sometime if you want to know how to do it. But I already flogged acceleration and kinematics last unit, Zach, so I'm not going to go all over it now. I guess there must be a distance. I'm going to argue that to pass each other, the back of this train has to get over to the back of that train. I think that's the distance. I think the distance is 120 plus 450 plus 80. Trying out a new calculator. Haven't bought it yet, but let's see if I like this one. Maybe this one is a little nicer. 120 plus 450 plus 80. And I get a distance of 650. And then I guess I need there's two objects moving. I'm going to use relative speed. What's the relative speed of these two objects? Is it 16 or is it 4? How do you know? How do you know to add? And the way I remember, head-on collisions are worse, so you're combining the velocities, okay? So VREL is 16. Once I have that, it ends up being D equals VREL times T. What happened to the plus a half AT squared? A is 0. Why is it VREL? Actually, we've got two objects moving. We're pretending one is standing still and the other one is actually the one moving at 16. So let's make a little note with the relative to remind us that we're doing that. It wants us to find time. Time is going to be D over relative speed. So it's going to be 450 over 16. 650. Why did I write 450? I was looking at the number in the picture and didn't look at what I listed. So 650 divided by 16, and I get, this one's going to give me fractions, 40.6. Is that correct, folks? If you got that, 3 out of 3. Okay. Otherwise, I would probably give you a half mark if I saw that you'd clued in that the distance was 650. I would give you 1 whole mark if I saw that 16, because to me, that's the aha key moment. I would give you 1 mark if I saw that equation right there. That's up to 2.5, and I would probably give you a half mark for the answer. Something like that. Number 2, same kind of question, but now they're going in the same direction. So again, I'm going to say, I guess they're asking me to find time. Because two objects are moving at different speeds, A is 0. D is going to be, I think for this train to pass the front train, the back end has to get all the way past the front end. I think the distance is 150 plus 450 plus 100. The distance is 700, is that right? And again, I'm going to use relative speed. The relative speed here, what is the relative speed here? How fast are they going relative to each other? 8. So as far as I'm concerned, on your test, when's your test? On Tuesday, I can give you any 2 of these and ask you to find the third. I can give you the relative speed and the time and say how far. I can give you how far and the relative speed and say how long did it take. I can give you how far and the time and say, hey, what must the relative speed be? Fair enough? Because hopefully you can get whatever you need to by itself. Again, it's going to be D equals VREL times T. T equals D over relative speed. So it's going to be 700 divided by 8. 87.5. In seconds. Again, 3 out of 3 if you got that. Again, I would probably give you a half mark if I saw the 700. I'd probably give you 1 mark for getting the relative speed. I would give you 1 mark if I saw that equation, and a half mark for the answer. What other questions can I ask about relative speed? Well, if you remember from quiz 1, and I know a lot of you didn't do quiz 1, says Mr. Dewick. Are you still grumpy about that, Mr. Dewick? Yes, I am. But another good question would be rabbit chasing, a predator chasing a prey. Or police car going after bad guys. Okay? That's pretty much what you're going to see for relative speed questions, I think. What about for relativity questions? So we already did a bunch on the last quiz involving time, t0, t, and v when you knew t and t0. Can also ask you stuff involving L, L0, M, and M0. So what length would the spaceship, you know what, 620 meters long measured when the spaceship is stationary. I'm pretty sure we use capitals, Mr. Dewick. L0 is 620. I think they want me to find L. So the equation is L equals L0 times the square root of that thingy. It's going to be 620 times the square root of 1 minus 0.96 c over c all squared. Lena, do you see? Do you see? What do you see? Always convenient. And so on my calculator, it's going to be 620 times... Where's my square root button? I notice on this calculator, it does the fancy indent. Most of you don't have that, so most of you would have to put a bracket there and go 1 minus 0.96 squared. I think on this calculator, because it extends the square root bar, I could get away with without putting the square root in brackets. But figure out your calculator. Y'all get, 173.6? If 174, I'll go to the full answer. 173.6 meters. A 45-meter long asteroid is shot past a stationary space station. How long? Okay, what length do the people on board? It's moving past them. They're going to see it shorter. So I think L0 is 45. It wasn't as obvious this time because it didn't include the phrase stationary or at rest. But I said, wait a minute, what would I see if I see that rock or that asteroid moving past? It's going to be shorter. And the shorter one is the relativistic length L. That's what this question wants me to find. It's going to be L equals L0 times the square root function. It's going to be 45 times 1 minus 0.98 c over c all squared. Do you see? Do you see? Yes, I see. And I'm going to get 45 times square root of bracket 1 minus 0.98 squared. Oh, yeah, that works. Close bracket. And do you get 8.995 or 9.46? Is that 5 going to stay a 5 or become a 6? It's 5. Okay, so 8.95. You could say 9.0, and I would say, yeah, but let's not round off to 2 sig figs. Let's go to at least 3. You could say 8.955. I would take that. If you said 8.954, I'd take a half mark off. But I'm going to go 8.95. Units, meters. Okay. Oh, for both of these, it would probably be something like this. 1 mark for that. Half mark for the numbers, half mark for the answers. 1 mark for that, half mark for the numbers, half mark for the answers. Ooh, they want me to find a mass. You know what? I think they're asking me to find M. I think M0 is 65. Okay, I think the mass equation, am I right? Is it M0 divided by the square root thingy? Okay, I'm going from memory and I always get these. They all look alike. It's easy to get them mixed up, so use your formula sheet. It's going to be 65 divided by the square root of 1 minus 0.99 c over c Don't forget the squared, Mr. Dewick. It's going to be 65. Ooh, I can use my fancy schmancy fraction button. 65 divided by square root of bracket 1 minus 0.99 squared. You get 461 or 460.8. I'll go 461. Units, kilograms. And I think we mentioned this is why we can't, one of the reasons, there's other reasons, but this is one of the reasons we can never get an object to the speed of light, because its mass would increase to infinity. You need an infinite amount of energy to get an infinite mass going the speed of light. I think this one is asking me to find L0. How long is it at rest? So that must mean that 144 is L. Yes, it's moving past me, and I measured it while it was moving. So I'm going to have to get the L0 by itself. L0, is that going to be L divided by the square root thingy? I think. It's going to be 144 divided by, I keep calling it the square root thingy. It's really the Lorentz factor, so I should use the fancy name because I'm a nerd. So it's going to be 144 divided, I could use my fraction button, it's the square root of bracket 1 minus 0.98 squared, close off the bracket. 723.6, which if you go to Wikipedia and look, oh, this is the Enterprise C. I think I used the one from the Next Generation, not the original Enterprise, because of course a Star Trek nerd would want me to identify which version of the Enterprise I was talking about. I like Captain Picard more than Captain Kirk. Sorry. Who? Yeah. At a Star Trek convention, those are fighting words. Number 7, I had to think about this for a bit. I kind of imagined the Ferrari kind of looking like that and whizzing this way. And I said, you know what? This is what's going to shrink. It's not going to shrink in this direction, in the vertical direction. So that 5.6 isn't going to change at all. What's going to change is the 18. So I said, I think L0 is 18. I think they want me to find L. So L is going to be L0 times the Lorentz contraction. So it's going to be 18 times the square root of 1 minus 0.95 C over C all squared. C cancels. It's going to be 18 times the square root of bracket 1 minus 0.95. Don't forget the squared square root. And I get 5.62. Meters. Your friend has been gone for 5 hours of your time. Okay, that 5 hours, is that T or T0? Oh, he's the one that's moved. Okay, so this wants me to find T0 because I'm the one that's at rest back home on Earth. I need to get the T0 by itself. Is it going to be T0 equals, do I multiply by the square root function, I think? I should have, before I put the number in, put the T there. So it's going to be 5 times the square root of 1 minus, what was it, 0.95 C over C all squared. Yep. And I get 1.56. Is that right? Now, just a little note. This is 1.56 hours. This is not 1 hour, 56 minutes, because hours aren't out of 100. How many minutes are in an hour? Yeah, what a stupid system we came up with for time. Why isn't it out of 10 or out of 100? But yeah, every once in a while I'll see a kid say, isn't that 1 hour, 56 minutes? No. How many minutes? How would I convert that to minutes if just not asking you this on a test, just out of curiosity. How would you convert 1 hour to minutes? How many minutes in 1 hour? How many minutes in 2 hours? What would you do with a 2 to get 120? What would you do with a 1 to get 60? By what? 1 times what is 60? 2 times what is 120? Huh? You know what? If I wanted to convert this to minutes, I would just multiply by 60, and I would say, oh, it's, yeah, nice answer, 94 minutes, a little more than an hour and a half. Oh yeah, of course it's a little more than an hour and a half, because 0.56 is a little more than a half. So don't think this is 1 hour, 56 minutes. By the way, in the future, this could lead to some arguments, because your friend says to you, I want to borrow this for 5 hours. You say, sure. And then your friend comes back and you say, you're done. No. I wanted to borrow this for 5 hours. I've still got almost 3.5 hours left, your friend says. No, you say. 5 hours has gone by. What if he goes even faster? His 5 hours could be days for you. He could be gone with your car for days. I have no way of knowing. Future arguments. This one's not so tough anymore because I gave you the V equation. So V equals C square root of 1 minus, is it M0 over M squared, or is it M over M0 squared? I just know it's one of those. That one? Okay. That was kind of a guess, but I had a 50-50 shot. Did this question say it wants the answer as a percentage of the speed of light? Everybody say no. Did this question say it wants it in meters per second? This is a bad question. I wouldn't let this get on the test, but what this means is I'll take either or both. So first I'll do it as a percentage. That means I'm just going to leave the C as a C, and it's going to be 1 minus M0 is the smaller one. M is the bigger one, all squared. So it's going to end up being the square root of bracket 1 minus, 1 minus, and then open up another bracket, 2 divided by 4, close that bracket, squared, close off the square root, and I get 0.866 or 86.6%. So one answer I would take is either 0.866C or 86.6% of C. I kind of have accidentally memorized this one. I noticed this is doubling the mass. If you want to double the mass or double the time or cut the length in half, I know it's 86.6% of the speed of light. I just memorized that one because it shows up in questions quite often. What about as a number? Then I would take this and I would multiply it by 3 times 10 to the 8th. And if I do that, I get 2.598 times 10 to the 8th. You could say 2.6, I'm not going to freak out, but usually for these ones, I tend to go to 4 sig figs or so because we're being pretty accurate here. So I would take either of those. By far the most common silly mistake on this, especially for some reason when I ask for a percentage, kids forget to square root. The number of times I've seen kids go 1 minus bracket 2 divided by 4 bracket squared. Because you get something that kind of looks like a percent. Oh, 75%. They'll tell me, no, you forgot square root. So don't do that. I like number 9, I like number 9, I like number 9. Number 9 is a nice question. There is going to be a star travel question on your test. Now, Part A, we haven't started moving yet. It wants me to find time in Part A, but I'm not going to use any relativity stuff. A is still 0 for this whole question because we don't know yet how to deal with relativistic acceleration. We'll talk about that on Monday, but we're not going to do the math. The math is crazy. D is 40 light years from Earth. V is 0.995 C. I'm going to use D equals VT. I'm going to go T equals D. Why am I not using T and T0? We haven't gone anywhere yet. We haven't started yet. We're just using our regular physics. We'd like to know, because the Earth is at rest relative to that star at rest, how long it's going to take as far as we're concerned. How long do we have to staff the mission control room? It's going to be 40 light years divided by 0.995 c. Conveniently, I get an answer in years. It's going to be really close to 40 years because we're almost going at the speed of light. 40.2 years as far as we're concerned. It will not take that long for the people on the spaceship. So as measured by the observers on the spaceship, now I want to find time on board the spaceship. Time on board the spaceship is going to be time times the square root function. How much time? I'm going to write 40.2, but I'm going to use my answer button because it's sitting on my calculator. Times the square root of 1 minus 0.995 c over c all squared. Do you see? What do you see? So it's going to be answer button times the square root of bracket 1 minus 0.995 squared. As far as the spaceship is concerned, 4.015, I'll write 4.02, but I'll store this on my calculator. 4.015 I would take as well. A much shorter trip for them. What's the distance traveled? You can find this in two ways. You can go d equals vt relative to the spaceship. It's going to be time on board. Why does that work? Because as far as the spaceship is concerned, Dan, it's at rest. It's the universe that is moving. And because as far as the spaceship is concerned, it's at rest, it can use a non-relativistic, non-Einstein equation as far as it's concerned. If you do that, you'll get 0.995 c times 4.015a. You do get an answer in light years. If I go 0.995 times answer button, and I get 3.995 light years. If you rounded that to 4.0, I won't freak out, or 3.99, I'm fine with that. Is it 3.99? Yeah, because it's a 4, so you could have rounded and kept that a 9. The other way you could have done this is you could have said, actually, they're finding the universe is being shrunk in front of them, space-time, where L0 times the square root function, where their L0 is the original length that we measured, which was 40 light years, times the square root of 1 minus 0.995 c over c. What do you see? What do you see? And they're going to get 40 times the square root of bracket 1 minus 0.995 squared. And you get exactly the same answer, 3.995 light years. Okay. Can you give yourself a score, please, out of 26? If you need to lawyer with me, now is the time. Otherwise, if you'd be so kind as to pass the quizzes inwards.